the last two concepts that we will discuss for today's lesson is the area, moment of inertia, and neutral axis. So let's start with the I, which is area, moment of inertia. I, area, moment, inertia. And I'm sure you heard the term IG, IO, etc. in dynamics. That is the mass moment of inertia. So today we just basically replace the mass with the areas, then we call it area moment of inertia. So whatever apply in the mass moment of inertia, when you start at the intro to kinetics, and then you apply those mass moment of inertia in force acceleration, work energy, and impulse momentum in dynamics in engineering mechanics class. Then mass, and you can see when a mass moment of inertia, they depends both on geometry and the material property. We see the mass, right? How heavy it is. But for the areas, when it areas, purely geometry. So basically, for this one, it's purely the geometry properties of cross section. Geometry property of cross section. And I just remind you, when I use cross section, I say X section, so it means cross section. I use that previously, just remind in here. And then what is the purpose of area moment of inertia? Let's get back to the concept in dynamics. What is the purpose? What is the why we need to determine the mass moment of inertia? Do you recall? Why? No? Yes? So if you recall, the mass moment of inertia is resistant to angular acceleration. Resistant to angular acceleration. How about area moment of inertia? It also resistant, but it not to angular moments, angular acceleration. It resistant to bending. Resistant to bending. And for example, let me see, the cross section is for rectangle cross section. Rectangle cross section. So let's assume cross section is here with a rectangle, and we have the width B, the height of this rectangle cross section is H, and we have the horizontal axis. Horizontal axis is X, XX. And then we have vertical axis. Of course, it is Y. Then, what is the area moment of inertia in X direction? About X-axis, area moment of inertia about X-axis, it will be equal to B H cubed over 12. B H cubed over 12. And what if the area moment of inertia about Y-axis? You just flip it, equal to h b cube over 12. It look confusing, right? Look confusing because that you see something b h cube over 12 and the other h b cube over 12. So how can you be able to understand for certain axis? How can I find out the area moment of inertia for that axis with the rectangle, for example, here? So as you can see, you need to know where is the axis. Where is the axis? So, and in this case, for example, x. Then the the width, as you can see here, actually parallel to the x. B, you see the horizontal B, the width is B parallel to the x. And the h perpendicular to the x-axis. Then for that equation, as you can see, just for us to understand when equip b equip or h equip, it's very confusing. So you can say that will be parallel time perpendicular equip over 12. Make sense? And similar to the y-axis, for you to see that whether that equation will be true. Y-axis, then h is parallel. So h is not cube, right? H only power 1. You see that? The parallel is 1. Now for y-axis, b is perpendicular to the y. Then it b cube. So as you can see, perpendicular cube over 12. So as you can see, b h cube over 12 or h b cube over 12 depends on which axis when you take area moment of inertia. How to know that? To avoid confusion. So it will be parallel to that axis, it will be power 1. Perpendicular to that axis, the side that perpendicular to that axis, it will be cube divided by 12. Everyone good? So that parallel, perpendicular cube over 12. That easy to remember for that. How about other shape? You should say, okay, no, not all the cross section of a member is rectangles, right? Other shape. How can I find out the area moment of inertia? How? So let me use the reference or back side of the cover, right? Reference from inside of the back cover, right? From inside cover of your textbooks. And we have that, I have that in the canvas for the reference that we can use, print out for your reference and then for the exam as well. So that is the reference inside the cover of the textbook. Let me show you that here in canvas, and that is the back inside cover of your textbooks. You have the rectangle, you have 112b h cube, 112b cube h, all of that as you can see there, and then triangles, circle, semicircle, quarter circle, ellipse, all of that, the standard shape that you have. So you can find out where is the area moment of inertia for standard shape. Now the next question is, with the composite shape, how can we find out the area moment of inertia for the composite shape? Then that go back to similar to the concept that we do in the mass moment of inertia. If you recall, how can we find out the mass moment of inertia? Did we make a table? Exactly the same. We make a table for area moment of inertia. Just change whatever the mass, the m, you just change the area, the a, in that equation, in that table. Even the parallel axis theorem, we change the m with the a. Everything will be the same to determine the area moment of inertia. So we will apply that in worksheet for F and G, and I suggest you to practice. If you are not sure how to make a table, I suggest you go back to the intro to kinetics lesson that have the mass moment of inertia. It's exactly the same concept that use the table to solve, and the standard shape with from and use standard shape information to determine the area moment of inertia for the composite shape. So with that, we will remind you with the problem for F and for G. In a moment, let's continue with the last concept before we move to that problem. So the next concept is the neutral axis. Keep that in mind. When we continue with this class, we will refer a lot about the neutral axis. So what is the neutral axis? By definition, it is a line. Axis is a line, right? A line that passes through the centroid. Through the centroid. Do you recall what is centroid? Centroid is the center of geometry of the shape, and is parallel to x or y axis. So that we call it neutral axis. So let's draw one, for example, the cross section here in I shape. Okay, and assume the this is a symmetrical shape in x and y. So you have the centroid in that area. So the neutral axis is defined by the line that pass through the centroid and parallel to x or y. For example, this is parallel to x, so you have it an a neutral axis. And then similarly, we also have another neutral axis here. It also parallel to y axis, so that is the neutral axis you have. If you have another body, for example, the only symmetrical for y direction, only symmetrical for y direction. So the first step, you need to locate where is the centroid and where is the centroid. How to determine centroid? Go back to engineering mechanics. Make the table in the lesson centroid and distributed load in statics, not dynamics, to make a table and find out the centroid. By the way, in the mass moment of inertia, we also make the table to find out centroid in there. So find out the centroid, which is the center of the geometry, and then the neutral axis basically go through the centroid parallel to x, or that can also neutral axis parallel to y axis in there. Okay, so just remind how to find out centroid. That is the last two. How to find out centroid, because we talked about that here. So I just remind you to find out the centroid. We have two equations, for example, in 2D, x bar equal to sigma xi ai over sigma on the areas, and then y bar, you have it sigma or yi for each standard shape times the area of standard shape divided by the total area of the composite shape, and that is the one we study in static and dynamics.